Hi, it's Rob Patterson. I'd like to welcome you to my Tech Talk. Today I want to talk about uh, importing data in a flexible way. In particular, we're trying to import stimulation data. Now, stimulation data is, well, let me show you the real life example. The thing about stimulation data is that different vendors supply the data that they record during a stimulation job in slightly different spreadsheet formats. So here's an example. I'll call it stim data format 2. Uh, and as you can see, we've got a number of different stages. So here's stage 1, and during stage 1, here are the rates that things were pumped at, and here were the pressures, and here were the volumes, here's the time, that kind of thing. And then similarly, during stage 2, we have a set of rates and pressures and volumes and times. Uh, and we could write some code that would import this, but the problem du jour is that vendor B gives us a different spreadsheet. And it's the same kind of data. Once again, it is supplied, each worksheet, or at least some of the worksheets are stages. Stage 1, Stage 2, Stage 3, And each one of them has got a bunch of data. There's the time, there's the fluid type, there's the volume, and there's the rate, and etc., etc. So it's the same kind of data, but organized in a different way. And we want our application to be able to read that data. So there's a bit of an impedance mismatch. Well, that's something I like to say. It's an impedance mismatch problem. We've got our Java application, for example, and we don't really want to hard code that it only works with one vendor's spreadsheet. Instead, we want a mechanism that's flexible enough to be able to import, any vendor's spreadsheet. We know the commonalities. We know we're going to have to read a bunch of stages. We know for each stage, there's going to be time information. There's going to be volume information. There's going to be, rate information, pressure information. So those are the commonalities, and we want some mechanism to be able to suck that data out. One of the best ways to do that, I think, is taking advantage of something called a scripting language. So what is a scripting language? Well, in this case, it's where we use, we have our Java application and we want to be able to call a script, something that can be written by us or a support person or anyone, but call a script that does the bits that could possibly change. And that's what I'd like to demonstrate, is that exact kind of thing happening. So we've got our two real life, data formats here. So there's one format, and you saw the other one. And what I've done is I've got a little application here that uses a technology called Groovy. So what is Groovy? Groovy is a scripting language I should say it's a dynamic language, but it's also a scripting language. It's a nice dynamic language that looks a lot like Java. If you can read Java, you can probably read Groovy, no problem. They look so similar because it's just a dynamic version of Java. Think of it that way. One of the advantages, though, of Groovy is, well, there's quite a few, but the big advantage of Groovy that we want to take advantage of here is that not only can you write actual Groovy code and compile it, but you can also write Groovy code that executes as a script. In other words, we don't have to ship the Groovy code, and the end user can actually modify that Groovy code. And that's what I wanted to demonstrate here. So here I've got a little test project, and it's actually written in Groovy. It's written in Groovy because I was lazy. It could have been written in Java, But when we run it, and actually let's run it right now. We'll just start it up. You'll notice that it runs in the Java VM. You can see our nice little Java coffee cup up there. So it's just like a Java application. It could be a Java application. And if a Java application wants to call Groovy, all it needs to do actually is add one library. They've actually put all the Groovy things into one large jar file. That's very easy to get at. But in this case, I've written a Groovy application, and it's a very simple one. We pointed at an Excel file, and we also pointed at a Groovy script. And what it's going to do is this application here, it's going to open up that Excel file, and then it's going to use the Groovy script to actually pull out the pieces of information that's important. So let's see it in action. I'll just run it before we even go see the script. So let's just run it. So in this case, I'm reading stim format F2, which is this guy right here. So we're going to read in this spreadsheet here and suck that data out and import it. So using this Groovy script. Click import. So it's going out, it's opening that Excel spreadsheet, and it's gone through the data, and let's scroll up to the top here, and it figured out that there were 17 stages. And here's the data it extracted from stage 1. So, there's a time, there's a name, there's a volume, there's a pressure, there's a propant. The propant is optional, but later on you can see it's a 70-20 mix there. So that's the stuff it pulled out of this spreadsheet. Now, let's say though that we pointed at this other spreadsheet. That's this guy right here. Things are organized differently. In this spreadsheet, the tabs aren't called stage, they're called STG. So if I just point my script sucker at this other spreadsheet and say import, well, it's not going to do so well because I'm still running the Groovy script for the original spreadsheet. So yeah, that's not rocket science. But if I say, oh, this is format 1, let's use a script that is appropriate for reading format 1 and do the import. Then it opens that spreadsheet, runs our script, and this time it found 15 stages. And here's stage 1, and in this step here, there's a time, there's a name, there's a volume, there's a pressure, there's a propant, and there's even a remark section. So the commonalities, well, they're common. So yeah, we can see that the application, this application right here, it knows that it's interacting with the spreadsheet. It knows that it wants to go through the stages, and it wants to suck in this information, but it doesn't know where the data actually comes from. That's something that's held in our script. So let's take a closer look at how that's done. As a matter of fact, to start with, let's take a look at the Groovy script. So this is format 1, and this is the script I use for reading format 1. This script, well, first of all, it has a method called import stage info. So here's the method. Let's just skip over that for a second because that's just a method definition. The next part of the script is a for statement. It's like, where's the body? Well, this is what gets executed. This is a scripting language. We're saying, I want you to do this for statement, and I want you to, in the workbook, I want you to go through the worksheets, and I want you to visit each one of these worksheets, and if it starts with the word STG, and if it's visible, that's important, then I want you to do this import operation. So that's where we visit each one of them and import its data. Notice the visible thing here, that's kind of interesting. There's actually some tabs here, worksheets I should say, that are invisible. They're information we don't want to import. So a little bit of code here changes what we do. And during our import operation, what do we do? Well, in this particular case, we go to row 46. No shocker there, row 46, and through 99. Through 99, What does that mean? Well, in this case, that's a max. We know that the number of rows can change from stimulation to stimulation, so from stage to stage, sorry. So we just hard-coded our maximum. And we got some code here to skip over all of the stuff at the bottom that doesn't exist. So, it just skips right over that. So for each one of these, it builds a step and it sucks out the data from the appropriate row. So we know that when you're in row 46, the name is in column B. So it goes here, slick water. And the time is in column A. There's the time. And the volume is in column C. There's the volume, etc., etc., etc. Whereas for the other spreadsheet, we have a different set of rules. So here's the script that we would run to read the Format 2 spreadsheet. So for Format 2, that's this guy over here. The rules are a little different. In this case, we want to, similar thing. We want to say, is this a stage worksheet? So we go through all of the tabs. Each tab is a worksheet, and we say, is it a stage? And if it is, then import it. And the logic in this case for is it a stage is, does it start with the word or end with the word stage? So it goes through all these tabs and uses that design. And similarly, when we import each stage, well, we look in different rows. So in this particular spreadsheet, we need rows 16 through 44. So 16 through 44. So for this format of data, we know that it's a hard-coded number, 16 through 44. And the name is actually in row A. The time is in row E. Here's the time. That's in row E, etc., etc. So we just map where the data gets pulled from. So that's the advantage of this logic here. This is external to the application. It can be modified by us or our support people, and provides that level of abstraction that allows us to break things up nicely. So now that we've looked at the scripts that get used to import this flexible data, I'd like to go back to the actual hard-coded stuff. I don't like to use the word hard-coded, but basically this is code that for the most part doesn't change. This is the stuff that we write, we compile, we ship. So in this case, I have a sample application that's written in Groovy. Now, I could have actually written this in Java, and I could have just added the Groovy library. But to be honest, I'm just doing a little example today. So it was actually quicker to write this code in Groovy than it is in Java. I mean, Groovy's pretty groovy. No, I'm not going to go there. Anyways, this could be a Java application or it could be Groovy. In this case, it's Groovy. And that's almost irrelevant. So I'm going to start it up one more time, and I want to draw your attention to the fact that we do have that little coffee cup in the corner showing that this is, this is an application that's running in the Java virtual machine. Just wanted to show you that. Here's the code that actually does the import. So it's my importer class. And here's what happens when the user clicks on the button to actually perform an import. Now, first thing I need to mention is something called scriptum. So Groovy's got a couple different ways that we can actually read an Excel spreadsheet. And, an obvious choice is Apache. Apache's got some wonderful POI libraries for reading Excel data. But I wanted to take advantage of another cool thing in Groovy called scriptum. So scriptum is a way that Groovy can call COM, the common object model, or component object model. Sorry, it's been so long. So basically, I'm able to write like a VBA kind of application, a very simple application, and you'll see what I'm doing here. So firstly, up top here, I want to point out something. I created a list of stages. So this is a member variable, and we start by clearing that out. So we start out with an empty list of stages. I then create a bindings variable. And what is bindings? Well, bindings are the mechanism that we have our Groovy application or our Java application, doesn't matter, talk to our script. It's a way of passing data to the script and getting data back from the script. So this is our interface to the script. And one really nice thing about this binding concept is, we're calling a script, we're calling untrusted code. We're calling something that we don't have total control over. But by using bindings, we're able to say, please run something and give me a result back, and that's it. Now, yes, the script could do something, we don't know what the script can do. It's basically like a Java application, but ultimately it returns some results back and we process it. Pretty simple stuff. Now we're using the scriptum thing again. So here's where I create an ActiveX object. We actually create a COM object with the prog ID excel.application. So if you've got some COM experience, you know that basically we've created a COM object that that is an interface to Excel. This gives us basically a handle to Excel that we can communicate with. And using that, we're able to, open the file that we need to import. So we've literally, at this point in the program, we've created an instance of Excel that you don't see. It's just in memory. We've created this in-memory instance of Excel, and we've told Excel, please load the data. And it's done that. Now, the next two lines are really important to understand. This is where I pass some data from our application to those Groovy scripts. And our Groovy scripts really only need to know two main things. One, it needs this workbook object. Okay, this workbook object allows the script to do anything it wants in Excel. And you'll see that. So, the script actually uses the workbook object to pull data from various parts of the spreadsheet, etc., etc. The other thing we pass to our script is our stages variable. So this is an array list, and it starts out empty. But as the script runs, it's going to populate it. So the script will populate our list of stages, and when it's done, we've got a populated list of stages. Good stuff. This is the line that does the magic. This is where we create our Groovy shell. So basically we've created a class that can execute a Groovy script. And we've asked it to please execute this particular Groovy script. So this is where we instruct the application to read this file here, this file or that file, either one of them. So we ask it to run the script, and when it's done, we're able to read back the stages. So if we take a close look at the script, and let's do that for just a second. Let's take a closer look at the script. We can see two things. We can see workbook right here, and you'll notice there's only one instance of this variable. Workbook was something my application created. So the application creates the workbook object, and this just uses it. This literally takes workbook and asks for the worksheets and steps through those worksheets. And similarly, stages is right here. As it's processing the data, as it's importing the data, it just adds to the stage array. So that's how this script creates some data and passes it back. And what it passes back is, these stage objects. And these stage objects have got, a bunch of variables: name, time, volume, pressure, propant. And we're able to pass that back quite easily. Then we process the stage information and write it out. So that's how this all works. We got a big catch in the end. And you may say to yourself, well, why didn't you just have one catch right here? And the answer there is actually you will get exceptions. People don't write perfect scripts. So when an exception happens, you want to give the user as good an error message as possible. In this case, the user is me. When I didn't get my script just right, then, something would happen and I'd want to know that, oh, it's a property missing. You named a property wrong. Or, oh, this is a method missing. You've called a method that doesn't exist. So that's why we want to have this kind of a catch statement here. So that's it in a nutshell. Using Groovy, we're able to, kind of decouple this application from the spreadsheet format. So here we have the application. It knows the common things it needs to pull in. And it's able to use a script to pull in what's appropriate for whatever spreadsheet format it's given. It's pretty nice stuff, and I hope that this kind of information is useful to you. Thanks. Talk to you again.